All right, let's take a look at our last lesson on vertex forms. So, a quadratic function can be written in general form, y is equal to ax squared plus bx plus c, where a can't equal 0, otherwise it wouldn't have an x squared and wouldn't be quadratic. And this is useful for finding both the direction of the opening and the y-intercept. It's a very fast way of finding the y-intercept, which we'll see later. Vertex form, or standard form, is useful for finding the direction of the opening, the coordinates of the vertex, the axis symmetry, and the min-max value of the function, or the properties of the graph. This is our y is equal to a bracket x minus p squared plus q. So, if I'm recalling what we did with the last lesson, consider the graph of y is equal to -3 bracket x plus 2 squared plus 5. Describe the transformations required to obtain this function based on the original one. Well, I have 4 transformations. The a is negative, so it's going to be reflected across the x-axis. The a value isn't 1, so it has a vertical stretch by a factor of 3. The p-value is going to be the opposite of what it says. If it says x plus 2, it's actually going to be -2. So I have a horizontal translation. In this case, 2 units left. And finally, I have a vertical translation. Five units up. Based on the properties of this, because it is reflected, then that means that it's going to open downward. Or because I have a -a. The coordinates of the vertex are going to be at the p and the q value of -2 and 5. The equation of the axis symmetry is going to be x is equal to the p value, -2. For the min-max value, well, because it opens down, it's going to have a maximum, and it's a maximum of my q value, a maximum of 5. For the domain and the range, the domain is going to state that it's x, where it's going to keep moving to the left, keep moving to the right. X is an element of all real numbers, or XER. For the range, in this case, because it opens downwards, it's going to be that y has to be less than or equal to the maximum of 5, where YER. If I'm stating the x and the y-intercepts, well, the x-intercepts and the y-intercepts are going to be ones that I can pull from my calculator when I graph it out. The x-intercepts are going to be when y is equal to 0. The y-intercepts are going to be when x equals 0. So because the x-intercepts are when y equals 0, when you're doing the second trace to calculate on your calculator, it's going to show up as the zeros, or option 2. Or if you have a Casio, it's going to go, when you do the graph solve, be called the roots. And we'll get into why that is a little bit later. So in this case, I have a y-intercept, if x equals 0, of 7. The x-intercepts to 3 decimal places are going to be approximately -3.291, or negative 0.709. And if I'm using the transformations in order to graph this, then I'm going to take my original points, 0, 0, 1, 1, 2, 4, or negative 1, 1, negative 2, and 4. And then I'm going to reflect it, make the points negative. For y, I'm going to stretch it, so I'm going to triple the y values. And these ones are actually going to shoot off the graph. And then I'm going to move my points, like it says, where I'm going to wind up moving all these points 2 units to the left and then 5 units up. So I go left 2, up 5, and then take this point and go left 2 and up 5, left 2 up 5, left 2 up 5, and left 2 up 5. And then I'm going to draw what my graph looks like. If I'm graphing using key points, then that would be where I'm actually making a table of values based on the function. So I'm going to take my points and I'm going to state what are the x's going to be, what are the y's going to be. So that's when I could go into the table of values when I've graphed it into my calculator and then find that I have the point of negative 4 and negative 7. I have the point of negative 3 and 2. Negative 2 and negative 5. Oh, sorry, and positive 5. Negative 1 and 2, and 0 and negative 7. And then I'm just going to draw those points out on my graph. Negative 4, negative 7, negative 3 and 2, negative 2 and 5, negative 1 and 2, and 0 and negative 7. And then expand out my graph.